Hello, everyone, and thanks for joining us for today's webinar on AccuTemp gas equipment. As Connie mentioned, my name is Lauren Bryant. I am the marketing manager for the manufacturer partnership team at Partstown. And today I'm joined with today's presenters from our partners at AccuTemp, Daniel Cox, the field service engineer, and Andy Sojak, the help desk supervisor and field service engineer. Today, Daniel and Andy will discuss the process of installing commercial gas equipment, specifically the AccuTemp Evolution Steamer and the AccuSteam Griddle, along with some practices on gas verification, testing, and other preventative maintenance tips. With safety being Partstown's most important core value, I have to alert the audience that this content is geared towards certified service technicians. If you are an owner and operator on the line, you will also get some great insight into the installation process, along with some awesome tips about preventative maintenance. After we hear from our great experts, we'll leave a few minutes at the end for any Q&A you may also have, so please submit your questions. Now let's turn it over to Andy, who will get us started.
Thank you, Lauren. All right, once again, I'd like to thank Lauren and Connie for kind of helping us out with this presentation, and once again, thank you guys for participating. And as Lauren mentioned, so we've got Daniel Cox and myself, Andy Sojak. We are your experts, and today, as Lauren mentioned, we're going to be talking about gas installation specific to the Evolution Steamer and the AccuSteam Griddle. Now, one thing to note is these models are also available in electric. All right, so as far as the agenda for today is, as stated, why evaluating gas supply to ensure appliance maintenance are why that's important, as far as detail on the startup in regards to setting the gas pressures, and also we're going to discuss planned maintenance and as far as how often and why. And once again, as Lauren mentioned, this is the tasks described today will be specifically for qualified service technicians. And once again, as an end user, is just to familiarize yourself with the process and what's involved as far as installing gas equipment at your locations. All right, the first slide we're going to talk about here, we've got gas supply. And pretty much, not just AccuTemp, but pretty much any other manufacturer tell you that before installing any gas equipment, the first thing that should really be done is, depending on where the installation is, where the equipment is being installed at, is there enough gas supply to support the equipment based on the equipment's BTU rating. Now, this is a little chart that I actually pulled off I actually copied it from the web, as you can see. So here we've got pipe diameter, and we have pipe length. So looking at this chart, we're going to use the 1-inch pipe diameter for example. So let's say you got 1-inch pipe. Now this is for natural gas. And that 1-inch pipe at 10 feet can support 684,000 BTUs. 20 feet, that same pipe can support 470,000 BTUs. And at 30 feet, once again, you see it dropping to support 377,000 BTUs. A little FYI, remember 377,000 BTUs because we will be going back to it in a couple slides. And what I call it's gas supply, but it's also a gas verification. I've got a great example. Actually, just recently happened this week. We had a customer purchase a brand new AccuSteam Griddle. They installed it, and the griddle wouldn't light. I get a call, so we ended up sending service out there. And come to find out, they connected the griddle to a 2-pound system, meaning it had 56 inches of water column going to a griddle that can only handle 14 inches. Now, so it's the customer's responsibility at this point to go ahead and actually replace the valve and actually add a regulator. But once again, it's important to know what your pressure is and what that pressure can support. All right, so as in the length of pipe, each fitting also will equal a particular fitting will equal as far as feet in length. So let's say, for example, we have a regular 90-degree fitting. Once again, we're going to go back to our 1-inch diameter pipe. So that 90-degree fitting will equal 5.2 feet. So in other words, you could stretch that 90-degree fitting to 5.2 feet in length. So here's a little example of gas supply verification, and I kind of call it gas mapping. I know that I've heard that term used before. I actually tried Googling it, but I didn't find it, so I guess it's my term. But anyway, so I said it first. So we've got a 1-inch. So we've got a 1-inch pipe. We have a 90-degree fitting. And that total pipe length is going to be from here to here is going to be 25 feet. Now, as we said, we have a 90-degree fitting, and going back to the other slide, it's going to equal 5 feet. So we have a total of 30 feet. Now, in 2 slides ago, I said remember that number as far as how much can a 1-inch pipe, how many BTUs can a 1-inch pipe support at 30 feet? Looking up here, so we've got, let's say for example, this is a brand new restaurant and they're trying to hook everything up. So so using the same supply, do you want a fryer at 125? Do you want a combi, big combi, 250,000 BTUs, and then an AccuSteam Griddle, of course, at 90,000 BTUs, but you also want to stick a steamer in there at 60,000 BTUs. Now, kind of going back, remember that 1-inch pipe at 30 feet can only support 377,000 BTUs. So just between the fryer and combi, we're looking at 375,000 BTUs. So based on this map, that at this point, that 1-inch line cannot support the griddle, and it can definitely not support that steamer at 60,000 BTUs. So as they're building this restaurant, they would have to actually either split the load or actually install a larger diameter pipe to be able to support the necessary BTUs. Now, there are situations as far as AccuTemp where we'll have a customer that has issues with their equipment, and we will actually dispatch a technician and we'll ask them, please map the gas. And mapping the gas is exactly what you see here. How big is the line and what else is hooked up to the line? On our startup form, we'll ask you to record the gas pressure with everything on the line running. But as far as a gas map, if you're asked, this is what we're looking for, what's on the line, how big is the line, and we need to see how much it can support. And yes, there's been probably more times than we'd like where, based on the current setup, that piece of equipment wasn't able to run correctly because they just did not have the correct volume. Now, talking about volume, I'm not sure if this is confusing or not, but to kind of make it a little simplified is, like, let's say take a garden hose, your regular garden hose at 30 feet. Now, you put a sprinkler, one sprinkler at the end of that garden hose. And let's say, for argument's sake, that we get about 60 PSI of water. Now, one sprinkler, you turn on full blast, you got a nice rotation. Now, go ahead and add 2 more sprinklers to the same garden hose and turn it on. You'll see that now the rotation diameter has decreased, and that's kind of like how gas is, you know. So we need to know, okay, what we have and what we need, and that's what we're looking for when we talk about gas mapping or gas supply verification. So here's a little basic example. So we've got a fitting at 1 foot, we've got a extended 90-degree at 3 feet, then we have a 4-foot pipe or gas line. So this is really quick. So we add them up. We've got 8, and then of course let's go to 10. And if it's 1 inch, remember 10 feet can support over 600,000 BTUs. So obviously, if we can support 600,000 BTUs, your steamer will run because the steamer is only rated for 60,000. Now, one thing to remember is we want to be over 10%. Now, so in other words, if you go bare minimum, say, hey, I can hook this up, and yes, during my calculations, I've got exactly 60,000 BTUs running at this connection. Nope, add 10% of that. I want to see that connection be able to support 70,000 or 66,000 BTUs. And then from that point, we do have that 10% buffer. And this is kind of a little example of how AccuTemp likes to see their equipment connected, and it's probably standard across the board with other manufacturers. So we have our griddle, we have a 24-inch, we have a 36-inch, and we have a 48-inch. So we like to see the pipe, and obviously each piece of equipment should have its own shutoff valve, and the actual size of the line going to the griddle, for us, is a minimum of 3/4 inch. Steamer, so depending on the size, so steamer, we've got the same. You know, for steamer, we could probably get away with a 1/2 inch. I think a 1/2 inch can support a little over 80,000. But once again, that's minimum. You know, minimum, yeah, it's fine, but let's kind of bump it by 1/4 inch. So let's maybe 1 inch go into the griddle, and maybe 3/4 inch go into the steamer, just in case, so we're 100% sure that we have that supply and the griddle doesn't drop out during normal operation. And obviously, if something doesn't work in the kitchen, that's not good for the customer and also possibly for the manufacturer. And we will work and try to figure, and then we always work with our customers trying to figure it out what's going on. Now, the bottom was kind of more important. You see this connection here? You'll see they got one line coming in. Now, we have that split, and we have a separate tap going to each piece of equipment. Now, once again, we've probably seen this more times than what we'd like, but we've actually seen connections where they'll have one line going to, let's say, the bottom steamer, and then they'll put a fitting from the bottom steamer and actually start feeding the top steamer off the same connection off the bottom. And in those situations, what we find, either the top or bottom or both, the steamer will start going to an ignition lockout. Ignition lockout meaning is that it's no longer seeing flame and it shuts itself down for safety reasons. And we've seen this a lot, especially situations where it's intermittent. You know, it's intermittent connection. It's dropping out randomly, and of course, we send a technician out there and it's working fine. So at that point, that's when we start digging deeper into gas connection, gas supply, gas volume, gas pressures. All right, well, that being said, I'm going to go ahead and turn it over to my colleague, Mr. Dan Cox.
Thank you, Andy. So I am going to be talking a bit more about the internal checking of our equipment during the startup process. So this is designed to be done once the unit is connected to power and gas, and if necessary with a steamer, the optional water inlet has also been installed. The slide we'll discuss first is just the vital pieces of equipment you'll need to complete the startup process with our equipment. You will need a multimeter capable of reading DC microamps. Most techs will carry a digital manometer, I'm sure. We do advise carrying a water manometer as well as a backup in case you see a gas reading that you're not quite sure about. Always good to get a second opinion on that. So the first thing we'll discuss is the gas valve for the Evolution steamer. Now, you'll notice there are two pictures here. We have recently updated our valve design. This is the old valve from 2018 backwards, and this is the design that we will be moving forwards. The valve body is very similar, just a difference in the coil and the coil wiring. As we discussed earlier, this valve is capable of regulating the gas pressure within the unit. If you know that the pressure supplied to the steamer is over 14 inches water column or a 1/2 pound PSI, do not hook the gas up to this unit beforehand. You will break those valves. So we need to keep it below a 1/2 pound PSI. Once we've done that, we will hook up a manometer to this port here on the valve, and we will have the door to the steamer open. So long as the steamer is filled with water, the pilot valve, which is the valve on the left, will open as soon as the water level board is satisfied. That will let you see the static pressure of the line, what's being supplied to the steamer. Typically, we advise to have it at least above 7, but they will work on 6 if it is one steamer by itself. Once we close the door to the steamer, the second valve, which is the valve on the right, will open. At this point, the pressure should drop, and that is your dynamic pressure. We prefer to see this around 5 inches water column. There is about 1/2 a water column leeway on either side to get the better signal from the flame sense. We'll go into that later. But the standard we say is 5 inches water column. If that second valve opens and you see a higher or a lower pressure, it can be adjusted here or here. You'll have to remove the adjustment cap first. That'll give you access to the plastic regulator screw, which you can back out or push down to increase or decrease pressure. If we move on, this is the gas valve for our AccuSteam Griddle. You'll notice that the coils are very similar. It's a very similar design, just the tap is relocated for easier adjustment due to the reorientation of the valve, and the adjustment is in the same place underneath the pilot valve. Our griddles work in a similar way. You won't be able to see the static pressure for very long on these. When you first power the griddle on, the pilot valve is opened almost straight away, so long as there is no high limit or issues like that. You will see static pressure for around about 5 seconds. The ignition system will kick in, the main valve will open, and at that point you'll see your dynamic pressure. Again, dynamic pressure should be set to 5 inches water column, and that's across the board, any size griddle, 24, 36, 48, doesn't matter how many burners it has, 5 inches is the set standard for these griddles. But why is that so important? Well, the gas pressure can directly interact with how our ignition modules verify the flame has been established. We use flame sense rectification on our griddles and steamers, and that basically means the flame sensor has to be completely engulfed by flame in order to produce sufficient charge for the ignition module to keep the flame on, keep the gas on. On the Evolution steamer, you would check this flame sense at the ignition module itself. We've got a small picture here. There are 2 pins. We do recommend using alligator clips to connect to them because they are very small, and holding a multimeter probe to those is difficult while you're still trying to watch your own multimeter. With your multimeter connected and set to DC microamps, this is the symbol you should see on your multimeter. You would start ignition. If there is a successful ignition, you should see the flame sense almost immediately. It may start low and climb slightly higher. On steamers, we typically see between 4 and 6 DC microamps. If you see a much lower reading or a much higher reading, this could be a sign that the flame is in the wrong area. It's either too low on the burner or too high, and that would then feed back into your gas pressure. You'll want to check that you are at 5 inches water column. You may need to adjust to bring the flame into contact with the flame sensor. If we move forwards. Here we have the griddle, and again, we're going to be using DC microamps. The hookup is slightly different. We have an orange wire that connects to the flame sensor here. You will remove that orange wire, connect your positive probe to the orange wire and your negative to the rod, the flame sense rod, in series. The griddle will still work during this hookup. They won't go into ignition lockout unless there is a flame sense issue. You will power the unit on, read the flame sense. Griddles will be slightly lower than our steamers. You'll typically see something between 2.4 to 4 DC microamps. It will start low, and as those burners get warmer, it will increase that flame sense signal. If the flame sense signal is too low for any of our pieces of equipment, they will close the main valve, and then signal ignition lockout. With the steamer, you will see the ignition lockout code displayed here on the LED. There will be 3 flashes in rapid succession and then a pause. On the griddle, the front of the control panel has what we call the fault light. That will flash in 4-second intervals to signify an ignition lockout. The final thing I want to discuss today is planned maintenance, also to give you a good visual of what our flame sensors and igniters look like. So the one above here is for the steamer. We have our flame sense rod, grounding rod for the igniter, and the igniter probe itself. Below, we have the flame sensor for the griddle, and then, again, grounding rod and igniter probe for the griddle. In regards to how to take care of these, they should always be cleaned with an aluminum oxide abrasive. Never use sandpaper. I know it's rarer these days, but it still can cause a glassine buildup on the flame sensor that will prevent it from detecting the signal. And it will also eventually damage and require the flame sensor to be replaced. If you're having issues with gas equipment, you will always want to verify that your burner orifices are clear. There is one in the steamer to the right of the main valve, and there is one per burner on the griddle. Make sure all of your probes are cleaned, especially if you have a low flame sense, and these should be done, that should be done at least once a year. The last thing I'll touch upon is our ignition probe. There should be a gap of around about 1/8 of an inch, or 0.125, between the grounding probe and the igniter. If that spacing gets wider, it can cause the igniter spark to come further back. That can cause delayed ignition, backfires, which will eventually damage burners as well. So that gap is actually really important, and I highly advise you inspect that if you're having any kind of ignition issue with a piece of AccuTemp equipment. I'm going to hand it back over to Andy now. He's going to talk about any future opportunities to learn with AccuTemp.
Thank you, Dan. All right, so October 21st to the 24th, AccuTemp will be hosting a live training seminar. Once again, we'll be discussing evolution, but not just the gas, the electric, same with the AccuSteam Griddle, gas and electric, and also we'll be spending 2 days on AccuTemp's new Vision Combi. So if interested, please RSVP by October 7th. I do have the actual flyer with a little more information on it, and my email will be available after this presentation. Just feel free to email me directly regarding any questions to the presentation itself. Okay, last but not least, as far as kind of discuss a little bit how AccuTemp's service department works, we offer lifetime support and service. And what that means is if there's an AccuTemp piece of equipment in your kitchen, we will support that equipment for the lifetime of the said equipment itself. And one thing is AccuTemp employs fully factory-trained technicians, and our job pretty much is to assist technicians on the phone, technicians and or customers as far as dealing with their issues. And my guys have been directed that we stay on the phone until the issue is resolved and we have either the steamer's up and running, or the technician has a part number in hand, or the customer himself knows that support is coming in regards to a technician being dispatched to his location. And also, obviously, every manufacturer is, in regards to replacement parts, you always want to go OEM. Now, in my experience, I've been in this business going on 16 years I've been doing support, and Parstown is the one-stop shop for OEM. Never had any complaints, and their service is amazing. Lauren, I'm going to pass it to you.
Thanks, Andy and Dan, for sharing your expertise with us today. It looks like we have some questions from the audience. The first question is about the orange wire in the AccuSteam Griddle ignition and verification process. Is that orange wire the ignition wire is the question?
No, that is the wire that's going to the flame sensor, and that is so the way the flame sensor works is once flame hits it, it's going to produce a DC current, and that current is actually traveling from the probe down the orange wire to the ignition module. So that wire is for the flame sensor. The ignition wire is a little heavier. It kind of resembles like a spark plug wire. Does that answer the question?
I believe so. So we have one more, a couple more actually.
Okay.
And this is a confirmation or a clarifying question. Just confirming, if the unit is being installed and it needs a regulator, is the customer responsible for the regulator?
Most of the time, yes, but it really depends on what the package of the purchase was. Now, there are some AccuTemp, there are some customers who actually will purchase an installation package, and at that point, AccuTemp will be responsible to install the regulator, but I would have to say most of the time it's the customer's responsibility or the installer that the customer hired.
Thank you. The next question we have in queue is, if you could explain, how do you know when the flame sensor probe needs to be cleaned?
That's an easy one. Basically, once again, we're going back, whether steamer or griddle, is when we have our meter hooked up, we will look at what the actual DC current is. Now, for the steamer, they normally run between 4 and 6 DC microamps. So example, you got your meter on there, you're seeing 2.5. At that point, if you were to call into our tech support, our service department, we would advise pull the flame sensor and clean it, and most of the time we'll see that value has increased. And once again, on the steamer, they normally run between 4 and 5. So if it's lower than where it normally is, we'll clean it, but if cleaning doesn't work, at that point we would recommend replacement.
Awesome. And the last question I have in queue is, how long does a standard installation process usually take?
Well, that's a good one. It really depends. There's a bunch of factors. Obviously, does old equipment have to be removed? Does power have to need to be run? Is there additional plumbing? But let's say everything's in place and there's plenty of room, no old equipment. In regards to actually putting it in place, that could take a few people. But the actual startup portion of it, as far as getting the griddle set up to run for the customer, that probably take about an hour, give or take, as long as no issues. And obviously, so the hour, that's something we don't want to see rushed. We want to see technician, and once again, once he has it, he has to turn all the other equipment on. But once again, going back, probably a good hour.
Excellent. Thank you. Looks like we got all of the questions in queue. So I will thank all the attendees for attending today's webinar. More information on AccuTemp equipment will be headed your way in our post-event email, including the webinar replay and more troubleshooting tips, along with the contact information for both Daniel and Andy. Please make sure to complete the short survey that will show up on your screen as the webinar ends. We love to offer more events like this in the future, so your feedback will help inform us of the topics, format, and timing that best meets your needs. Thanks also to our presenters from AccuTemp for your time and valuable information provided today. Everyone, have a great afternoon, and thank you.